This is Newton's Three Laws by Jaleesa Livingstone and Tobias Viera.
As Toby shoots the ball behind me, Newton's first law is being applied because the basketball has a constant speed and motion as he shoots it. Behind me, Toby is presenting the Newton's second law because the greater force he puts on the ball, it goes further, and the less force he puts, it doesn't go as far.
Okay, so I am demonstrating Newton's third law by putting an appropriate amount of force to the mass of the ball. Because I am right in front of the catcher. If I applied a little force to the ball, it would not go to the catcher. But on the other hand, if I applied too much force to the ball, it would also not go anywhere, which is the catcher's hands. In the beginning of the video, basketball explains that Newton's first law can be represented if you throw a basketball at a hoop, but that's not the only way that Newton's first law can be taken. On the other hand, Newton's first law equation is F equals ma, so that means that force equals mass times acceleration. Not only Newton's first law can be represented in different ways, but Newton's second law can be demonstrated in different ways too in the sport of basketball. For example, it takes place in the picture above. But there is an equation to it too. The equation is F divided by m equals a. Force divided by the mass equals the acceleration of the ball. The girl pushes on the ball pushes back on the girl, but friction keeps the girl in place. In this picture above, it demonstrates another example of Newton's third law of motion, even though there are still many to be brought upon in basketball. There is also a way to explain Newton's third law. In the picture above, it says force A and force B with arrows in the middle. This demonstrates that if they come together, they both have equal and opposite reaction. It's weird how Newton's law can tie into such thing as a TV remote, but actually Newton's three laws can occur everywhere around us. With many objects in the world, many people don't know about the Newton's three laws being tied into them, for example, a TV remote. It does sound weird, but Newton's first law can tie in to a TV remote. For example, this law takes place as you touch the remote that lays restless on my binder. What I am doing is letting the remote be at rest until I decide to pick it up from my binder. Newton's first law of motion states that if forces upon an object are balanced, the velocity of the object wouldn't change at all. In case you're wondering, velocity is the speed of an object in a given direction. Therefore, Newton's first law does tie into a TV remote because the TV remote velocity does not change at all as I pick it up from my binder.